Welcome to this explainer. If you've been tracking the rapid evolution of multi-agent engineering lately, well, you know exactly how quickly things can devolve into absolute chaos. When AI agents are just left to interact freely, it gets messy fast. So today we're unpacking AXP, or Agentic Extreme Programming. It's a rigorous, protocol-driven methodology designed to tame that exact chaos, and it literally transforms unpredictable interactions into a typed, governed, and highly professional enterprise system.
We have got a really packed agenda today. We'll be mapping the journey all the way from the foundational philosophy of AXP right down to a real-world case study. So we're going to cover adapting AXP for agents, look at the protocol-first system, formal governance, discovery and build loops, and then we'll finish up with the White Paper Studio case study before summarizing the whole shebang.
Section 1, Adapting XP for Agents, bringing rigorous engineering to multi-agent work. Let's dive in and look at exactly why traditional multi-agent systems need such a massive structural overhaul.
Right, so this is the million-dollar question, isn't it? How do we predictably organize multi-agent systems without them descending into what AXP brilliantly calls unstructured chat residue? Because nobody wants that. This is the absolute core problem AXP solves. It takes its inspiration directly from traditional software engineering, specifically extreme programming and solid design principles. And it treats agents as role-bound producers. They're governed by explicit contracts, strictly scoped tools, and mandatory verification. No more free-for-alls.
Section 2. The Protocol-First System, Building the Machine-Checkable Graph. Let's see how AXP fundamentally restructures how these agents actually collaborate.
Consider this paradigm shift, because it's a real game changer. In the old way of working, a senior architect agent might directly call a database engineer agent by name, right? It creates this chaotic web of direct, fragile dependencies. But under ASXP, it's completely different. The senior architect produces a very specific, versioned artifact, say architecture.solution.v1. The database engineer then consumes that artifact, so agents do not freely chat with each other. They connect via typed protocols, making the entire system statically analyzable from the outside.
So a protocol basically acts as a strict socket, or a typed port. Think of it literally, like highly technical plumbing infrastructure. Skills can only connect when their input and output ports perfectly match up. AXP strictly defines what these artifacts look like and the guarantees they absolutely must carry, categorizing them into types like architecture, governance, or data and API implementations. What this means for us is that you can seamlessly substitute any agent in the pipeline, as long as it meets the protocol's guarantees.
And every single important artifact in AXP shares this bimodal structure. It is such a smart approach. On one side, you've got machine-checkable rules, typically written as YAML front matter, which outline strict constraints like token budgets. Then, on the other side, you have the human judgment layer. This is the pros explaining the rationale and the trade-offs. By separating the rigid system constraints from the nuanced project logic, AXP allows automated evaluation harnesses to mechanically enforce the pipeline while still capturing that essential human-like reasoning.
Moving on to Section 3, Governance and Formal Escalation, replacing chat with durable decisions. Now, what happens when things inevitably go wrong, or when agents disagree?
Well, AXP handles ambiguity and conflict without relying on those endless, super expensive agent deliberation loops we've all seen. Instead, it uses a ring of formal governance forums, which are actually multi-agent deliberation bodies themselves. Look at the range we have here. You've got a murder board, which is this ephemeral, highly adversarial forum triggered specifically to pressure test high-risk proposals. On the other end of the spectrum, the tribunal acts as a binding deadlock resolver. So instead of agents just talking in circles forever, this structure ensures that decisions become durable, documented artifacts.
Section 4, Discovery and Build Loops, the standard project lifecycle. Let's map out the actual journey of a project moving through this methodology.
The standard project lifecycle kicks off with the discovery phase. It is heavily front-loaded and completely artifact-driven, building really durable context before a single line of build work even begins. The absolute most important gate here is the customer proxy sign-off. That has to happen before the architecture board even looks at project decisions. It's essentially an enterprise-grade safety check, ensuring stakeholder intent is perfectly locked in before any design artifacts are generated.
Once discovery is totally complete and that context is locked in, we enter the build phase. Now, this iteration loop is entirely driven by composite closed triggers, not just arbitrary time boxes. Project manager and orchestrator skills plan the iteration, producer skills build the actual implementations, and a QA pair reconciles the test plans. Crucially, and this is a big takeaway, feature completion rather than just running out of time on a clock is AXP's final definition of done.
Throughout this entire lifecycle, from your day 1 sign-off all the way to logging a new defect on day 8, the project journal acts as the golden thread. It continuously captures the temporal narrative of the work, always securely stacking the newest events right on top. This is absolutely crucial because it gives human stakeholders a perfectly linear, highly transparent view into exactly how the multi-agent system reached its current state.
Section 5, Case Study, White Paper Studio, AXP on AXP in action. Okay, let's ground this whole system architecture tour with a concrete, real-world example. The White Paper Studio project is absolutely fascinating because it's an AXP on AXP project. What does that mean? It means the AXP methodology is actually using itself to output a completely new kind of deliverable, a highly governed agentic workflow. So instead of writing standard software, the project is producing a reusable multi-agent writing team, which is tasked with delivering a candidate white paper and a visual explainer. It's very meta, but it works brilliantly. To pull this off, the project organizes a highly specialized roster of producer skills. You've got a narrative lead, a section drafter, a citation verifier, a voice editor, and a diagram author. And remembering our core rule from earlier, they are collaborating actively through document protocols like document.outline.v1 rather than just direct prompting. Plus, they're being reviewed by an adversarial murder board and a constructive editorial board.
Now, setting things up this way intentionally exposes what they call substrate friction. Because AXP is originally shaped like a software system, adapting it for pros highlights certain gaps, like build gates assuming code tests instead of document reviews. But a core philosophical value of AXP is used to fix, meaning the methodology only evolves when actual, observed, real-world project friction proves that an evolution is strictly necessary. We do not mutate stable contracts just based on speculation.
Finally, Section 6, Summary of AXP, the core methodology invariant. Let's conclude our explainer with a high-level summary of the massive paradigm shift we've explored today.
If you take away just one single invariant from this entire framework, let it be this. Skills do not depend on each other directly. They depend on protocols. By firmly enforcing this rule, along with adversarial verification and strict governance, AXP successfully transforms chaotic multi-agent chat into a typed, governed, and truly professional engineering system. So the next time you're faced with a complex multi-agent task, you have to ask yourself, are your agents just chatting, or are they bound by protocol? Thank you so much for joining me on this explainer, and I will see you in the next one.